Hello everybody, my name is Peter Klaas and today I will be showing you an example in Houdini of a trail operation. So I will be using a little bit of SOPs, POPs and VOPs for this. So as you can see, the color kind of fades off over the trail, and the same for the alpha value, right? And we'll be seeing a few different ways along the way how to approach things. Yeah. So let's get started. Right. So first of all, what I want to do is make a little bit of space. So I've got a bit of space to work with, and I'm going to create a box. Right, I don't need the file anymore at the moment. I'm going to create a box by pressing Control left mouse button click on the box in the shell. This will automatically lay down a box for me, make a box geometry object, and I jump inside, and there's my box. Jumped inside by pressing I. Okay, so let's assume that this box is a dummy object and it could be a sword. So in order to get a nice kind of trail, I want a long object, so I'm going to add a transform to this. Just right click on the outputs and start typing transform. Alright, and then I'm going to scale it a little bit, so something like 0.1 and 10. So there we go. So it's a lot flatter now and it's a lot longer. So let's make the point numbers available as well. We'll be using that in a bit. I want to start moving my box around, so a little bit of funky movement. Yeah, I don't need that. So basically I'm going to add an expression which is sign $FF, yeah, in order to have it move. So it's a sign of floating frame, and I'm going to add this as well to the other channel. So at the moment I've just got a little bit of movement and it's very slow, so I'm gonna up the frequency, so the movement is gonna speed up, and I'm also going to up the amplitude, so the movement is going to increase in in amplitude. So let's say this is going to be a broad movement, something like a slow broad movement, something like 2 by 10. So 2 for the frequency, 10 for the amplitude multiplier. For the other direction, I'm going to say, okay, I want to multiply this by 4, so a faster frequency than the previous one, and something like 5. So this is going to be a big slow movement, and this is going to be a fast, smaller movement. Yeah, and combined, this will give us. This will basically give us something like this, which is fine. Okay, this is a little accident, but let's just adjust this so that we change this to $FF as a starting point. So we're going to use $FF, which is again the floating frame, the time, to drive the rotation in X, in Y, and in Z. Alright. So as we can see now, it's all nicely rotating, which is fine. I want to have this rotate a little bit faster, this guy as well. Yeah, and this should give an interesting result. Okay, so that's fine. So this will be used now. So from there, basically what I want to do is I want to grab some of the points that I've got there. I'm going to hide my grid. I want to grab some of the points that I have. So say point 0 and the corresponding point at the top, and put them inside of a group. Then from that point I will start emitting particles, so start emitting a trail, and that trail will then be turned into a curve. That curve, or those curves, those generated curves, will then be used to create a surface. So first of all, let's add a group to this, yeah? And I'm going to name the group _A, and I'm going to put down $OS, which is a variable that will basically look for the name of the operator. So the operator name in this case is group _A, so the group name will also be group _A because it's being referenced. Alright, and put this down. I'm going to change my entity to points, yeah? And I'm going to go and grab the correct point. So the point that I'm looking for, I pressed space G to home up on my object, and the point that I'm looking for is 0. So I'm going to scroll down a little bit, group by pattern is fine, and we're going to type in 0 to grab point 0. Yeah. Later on, if you make this into a more procedural example, you can put in your own, pattern point and it'll automatically update and all that. Alright, so that's fine. If I middle mouse button in this, you can now see 1 point groups, 1 point in group A. That's fine. Let's add a new group. So same thing again, add a new group. I'm gonna grab the one at the top this time. So let's call this one group underscore B. I'm again going to get my $OS, so my operator name, the primitive type, or sorry, the entity is points, and by pattern, in this case, 0 there and 4 at the top. So I'm going to put in 4. So now I've got my 2 points. I've got 1 point in there and 1 point in there. So 1 point in group A, 1 point in group B. That's cool. Alright, so from here we're gonna jump into particles. So particles, I'm going to lay down a pop network. So basically we're gonna jump in a different context. So pop network, right? And note as well that this connection is going into the first context, into the first input of my pop network. So I'm gonna make this visible. And the first thing I want to do is lay down a source operator so that we can start to emit particles. I'm going to say the geometry source is the first context geometry, right? So basically that means nothing more than just use the one that is input in there. This is the second context, third and fourth context. First input. So then the source group that I want to use for a start is group A. So over there, group A, which basically will allow my particles to be emitted as I start going. You can see the particles are being emitted from that point, which is fine. The problem, however, that I'm having at the moment is, as you can see, there's like 0, 5, whatever, 15, 20, and so on. There's multiple particles, occupying the same space. So which means that basically there's more particles being emitted per frame than I really want to. So I'm gonna switch to the birth tab. So over there in the birth tab, what I'm looking for is the constant birth rate. What is going on at the moment is there's 100 particles being emitted per second. Now a second at the moment, my settings are default, in Houdini is set to 24 frames. So in 24 frames, 100 particles are being emitted, which is way too much. In order to correct this so that only one particle is being emitted per frame, I'm going to change this value to 24. So as I start by pressing arrow forward, as I run through my particles, you can now see that 0, 1, 2, 3, 4. So every frame one particle is generated because it's 24 particles per second. I can automate this in order to put in a little expression. So FPS is frames per second. So again, this is going to give exactly the same result, but if I now change, or somebody changes, the timeline, it's gonna update to 25 for PAL, 30 for NTSC. Alright, and there we go. There's my trail. So that's good. The other thing that I'm going to do as well is kind of change, the lifespan of my particles, because at the moment, well, they only die after 100 seconds, which is a very long time. So what I'm going to do is change this to something more reasonable, like 2, and now my particles will live for twice this, so it's 48 frames, so they live for 2 seconds. So they should start dying after a while if I remind them again, and they start dying after 50 frames. You can kind of see how they update. Now note as well that the point number is updating as well. So I'm not using the ID of the particle, but it's actually the point number, so this is quite convenient. Alright, I'm going to start adding some color to them now. So let's hide the point numbers and just add a color operator. There's the color. Alright, what I want is a ramp, and I want my ramp to kind of vary a little bit in color. So first of all, let's start with the most important thing, and that's actually the lookup value. The lookup value will basically be the input of where the ramp is sampled from. So at the moment it's sampled from the frames over the maximum number of frames. The current frame over the maximum number of frames. What I want to sample it from is life. So now it's going to sample it from $life. So as you can already start to see in the viewport, it's going from black to white. So it's going from the first, which is 0, to white, which is 1. $life is a particle attribute that is normalized. So basically that means that it goes from 0 to 1, and the ramp corresponds to that. So let's change these values a little bit. Let's bring in some color, so something like a yellowish kind of color there, so something like that. This can be white. This one can be orangey, maybe something bluish in there, light blue and a dark blue as well. Yeah, so something like this could be interesting. Alright, so that's good. Then from there I'm gonna leave this one in white so that we can kind of identify easier. If I would make this black, then you cannot really see because my background will be black as well. If I leave it white, then you will see where the alpha starts to come in. So just for example purposes, normally you would give this some darker color or so. Okay, what I can do now is either add the alpha here, so in the alpha, change this to ramp as well, and either add the alpha there, start adjusting this, but then I need to use all these values and I don't really want to do that, so I'm just going to add a new color operation on the back of this and change it there. So I'm going to say pass for the alpha, color is fine, it's a ramp, so we'll leave it at that. Add a color over there, again a color, and I'm quickly just going to add an underscore and say alpha, so I know that this is actually where I'm manipulating my alpha information. So again, change the tab to alpha, from color to alpha, very important, yeah, and start to adjust the ramp. So we've got a clean ramp now. I'm not looking at the big ramp at the top, but I'm actually looking at the ramp at the bottom. So what I'm looking for now is I'm gonna select this one and I'm gonna dial down his alpha value. So now you can see how this alpha value, being 1 over there and 0 over there, is going to fade off. Again, I need to change the lookup value and change this to $life. So if I rewind this, I'm going to turn off my point numbers. And there we go. Might not be visible yet. Just to make sure that we've got a little bit more visibility going on, I'm going to put in 2 more. Yeah. I'm going to change this one to 1 and change this one to black, so that I'm definitely sure that at the very end is completely black. Okay, something like this is fine. Rewind the particles. If you want to see the values, like on a per particle basis of this alpha or this color or whatever, then you can just bring up a spreadsheet, right mouse button on your color and bring up spreadsheet. In the spreadsheet you'll be able to see the different values the particles have, such as their positions, all their attributes basically, their life, their maximum life, so their current age and their maximum life, the color information and the alpha information. Now if I bring up my point numbers, so just bring up my point numbers, I'm gonna make this a little bit smaller, then you can kind of see that the last points are 0, 1, 2, 3, so basically the points over there, 0, 1, 2, 3, they should be the oldest, which basically means they should be completely transparent, and that's the case. The alpha there is 0, 0 and so on, right? And the earliest points are all 1. They're all completely visible, whereas these will start to fade off. Alright, so from there, moving on, we're gonna jump back up to subs. So this is fine, we'll be using this soon. Okay, so there are basically 2 ways to convert this into a curve that are fairly convenient. I'm going to show both at some point. Well, yeah, I'm going to show both. So first of all, let's do the first way is by adding an add operator, and this is going to turn it into a polygon curve. So switch to polygons and say by group, and immediately you can see that a line has been created as soon as I did that. Now there's a little problem, and you will start to see this as we go on, and that's basically that there are currently 2 primitives. There is 1 polygon and 1 particle system. Now at the moment that's not a problem at all, but once we start to use this and start to merge them together, so several curves, so let's do this, just as a start, just create our curves. Yeah. And at the moment also I need to change my second particle to take in group B, right? So otherwise, if I play this back, otherwise you'll see that they're both emitting from the same. So this guy is there and this guy is there. They're both emitting from the same group. So what I want to do there is jump inside quickly and just change my source, change this from, get rid of this group A and put group B in there. Yeah. Now if I rewind this, it's using the one at the top, which is fine. It's doing exactly the same thing with the color and stuff, because I just copied this, you know, the birth values, the constant stuff is all the same. Now, at some point I'll be changing this into a special kind of copy, into a reference copy, so you can optimize this network then. Alright, so let's say we try merging them together, yeah, these curves, so just select both of them, select one of the outputs and put it into the merge, and they'll automatically be, you know, merged together. So now I've got my two curves going on. Yeah. So there's my two curves. Problem is this will not give me a correct surface, so if I try skinning this, it will give an error, because I've still got particle systems in there, and the skinning operation does not know how to interpret this. So it's gonna say error, some primitives types in source geometry cannot be skinned. Okay, which primitive types? Well, you can see 4 primitives are there, 2 polygons and 2 particle systems. So I need to get rid of these particle systems and just keep the polygons. In order to do that, I'm going to add a delete in there. Yeah. Primitives is fine, and I'm going to delete a pattern. So let's have a look. So basically the pattern that I'm looking for, I've only got 2 primitives, so it's going to be either 0 or 1. So let's try this. So let's try 0, and I'm still seeing my polygons, so I know that I've just deleted my particle system, but to check, middle mouse button, you can see 1 primitive, 1 polygon, yeah, versus 2 primitives, 1 polygon, 2 primitives. So I was looking at this one. Okay, so this is fine. I'm going to add this as well to the other side of this, so let's unplug that and let's replug that. Okay, so now my skinning operation is working. It's doing its thing, so it's kinda doing the funky movement. Yeah. So there's my trailing operation. Now, don't worry about these kind of viewport drawing errors. This is OpenGL related. This is not actually gonna show up in the render. Okay, from there, I'm going to take a small detour before jumping into VOPs, because from here we're going to actually start working on the material. The detour that I'm going to take is, I'm going to show you an operation involving the creation of this kind of curve. So say how to go from this particle to this curve. The deletion and everything else will stay exactly the same, it's just another way of doing things, because I think it's very important this way. So basically, let's start by putting down a line operation. Yeah. So again, the same thing. Gonna make my grid available. Yeah. There's my line. Pressing space G to home in on my line. And I want to use the values of the points of the pop network. So those values you can see there. I want my line to be moved on top of them, so to speak. So first of all, what I will need to be doing is make sure that my line has the same amount of points as my pop net. Yeah? So how can I find this out? Well, a middle mouse button on them, and I know there's 50 points. But that's a bit of a problem, because this point value changes. I can't just type in there 50 points. Yeah, I mean, I can obviously type there, but it's going to change, because in the beginning there won't be 50 points. Like if I just move, like, say 7 frames, there's a lot less points. If I evaluate this one, something like that, there's only 13 points. Yeah? So this needs to update dynamically. So the way to go about doing that is if I just go to Windows, Xhelp, and I'm going to bring up a HScript text port. Yeah? So 2 main commands that are very important is the help command will bring up information on the help, and the other one is xhelp. Yeah? So the xhelp command will bring up information about various kinds of expressions. Yeah? So these are all the expressions that I can start using, and the one that I'm particularly interested in is the number of points. So this one, endpoints. So what I'm going to type to find out a little bit more information about this is xhelp endpoints. Endpoints. There. So what it says is basically this function return the number of points in the sub. -1 is returned if the sub cannot be cooked. Good. So basically what I need to do is type in endpoints and then a path to whatever sub that I'm using. So let's do that. Yeah, I'll just close this. So this is going to be endpoints, open, close bracket, and the one that I need is popnet1. Yeah. So basically, just start typing your path. So dot dot to jump one up, slash popnet1. We can already start choosing this. Yeah. So popnet1. So that's fine. Now, as you can see, yeah, if I evaluate this, yeah, you can see 13. So as I move my frame, yeah, you can see that it updates, yeah, because it's kind of sampling the values from there, which is fine, which is exactly what I need to, what I need to do. As well, at this point, might be useful, like later on to, since it's in the, in the default position, it's in the 0 to 1 space, you can now kind of apply UV information to this or something like that. But yeah, let's just go on with the example. So what I'm going to do is add a point, yeah, a point sub. And we're going to plug in the popnet into the second value. So basically what I want to do is use the transformation information, so the transform values of the points of the popnet, and I want to transfer this onto the transformation values of the line points. So the way to go about doing that is just by changing this position value to $tx2. Yeah. So now you can see the x values are lining up, and the y values are lining up, and now the z values are lining up. So now I just made my curve follow the exact same pattern. Now the same thing can be done with the other attributes, such as keep color. Yeah. So add color, and just say 2. And again 2, and once more 2. Yeah. Now the color is being transferred once more, the alpha, so add alpha, and the alpha is also being transferred. Yeah. So all my attributes at the moment are being transferred. If you've got your own custom attributes, you can do transfer stuff later on. But anyway, let's just see, and so as you can see now, the curve is just being colored and being moved to the correct position. Now the same problem remains, however, in the sense that we can just, we can just plug this in there, yeah, and we need to build up our surface and our shader. So that's fine, we could do it that way as well. So we don't need to delete anymore because we're not using our particles anymore. There's only one primitive in there, so this delete can be gone. So this would be just bypassed if you would see it like this. So we would copy this again, yeah, and we would plug in the popnet2 in there, yeah, and obviously this would need to sample popnet2, yeah, and then we would merge this together. Yeah, so these two, let's make sure they're kind of in the right order. So I mean the order is not really important, it's just trying to keep the network a little bit more clean. So these two up in there, yeah, and then this could just as well be plugged into the skin. Yeah. So it gives exactly the same result. Yeah. But it's just to show you a way. I mean, this shows you several kind of ways. First of all, shows you the transformation data is being transferred, which is a very, very useful thing to be able, as long as the point numbers are the same, you can just transfer the information this way by using tx2. The other thing is the number of points expression is very useful as well. You'll be using that. Okay, so just as a comparison, oops, wrong one. There, yeah, exactly the same thing. So at this point I'm also going to save the file, so just save, yeah, and we're going to jump into FOPS.